Hello class, today we're going to be going over 2.4, section 2.4, graphs of sine and cosine functions. And the first graph that I'm going to talk about is sine of x. A couple of things that we know about sine of x is that the period for sine of x, and the symbol that we're going to use for that is t, is 2 pi. We know it's the same for cosine, but I wanted to give that to you right off the bat. So that's one of the important things that we know. Now, with that, I picked some values on this table for us that were easy to find based off of the unit circle. So this first one, when x is 0, sine of 0 is going to be 0. So we know that the first point that we're going to pick is going to be the origin 0, 0. Then pi over 4 is going to be radical 2 over 2, and that's approximately 0.707. We know that sine of pi over 2 is 1. Sine of 3 pi over 4 is a radical 2 over 2, and that again is the same value of 0.707. Sine of pi is 0, so I should plot some of these points just to help you guys see it. So then we see that at pi over 2 it's 1, and then at pi again it's 0. At 5 pi over 2 it's radical 2 over 2. Now this is going to be a negative value, so it's a negative 0.707. At 3 pi over 2 it's going to be a negative 1. So we can put that value there. At 7 pi over 4, again, it's a negative radical 2 over 2, which is that same negative 0.707. And then 2 pi will again be 0. Now these are 5 of the key points. We know that the period is going to be this piece here, so that's one period. And the graph is going to look something like this. Now, because obviously sine doesn't stop there, and it is an odd function, we know that this thing's going to have points that go like this on the other side. And so this thing's going to go down and then up and then back down. Now, the important thing to see is that the period of sine, you can see it started at 0, if that's what you want to call your start point, and then it gets back to 0 at 2 pi, and then it repeats. So it's this wave that oscillates back and forth. Now, a couple of things that you want to know. The domain of this, the domain of sine, is going to be all reals. And the range for it, remember that the range is the y values. So the lowest y value that we can have is -1, and the highest y value that we're going to get is 1. So it's kind of restricted, right? It's going to stay in that range and oscillate up and down from -1 to 1. And that's the graph of sine of x. Now let's manipulate it a little bit and see what we can do. So this 3 here in front of sine of x is the amplitude. And so all this is going to do is take the values that we have and multiply them by 3. It doesn't change the period, so the period for this guy is still going to be 2 pi. And let's see if we can make some connections with that graph that we have above. So we know that at 0, it's still going to be 0. So everywhere it's 0. 0 times 3 is still going to be 0. So I'll put all the points that are still 0. And then let's look at the points that are like 1. So at pi over 2 in this graph up above, we see that's 1. So in this case, it's now going to be a 3. It's been amplified. At 3 pi over 2, we see it's going to become 3 times that -1, which would give me a -3. At negative pi over 2, it's going to be multiplied by 3. And at a -3 pi over 2, it's going to be multiplied by 3. And so this graph, the only difference is it's bigger waves. Try to draw it for you as best I can. Now, again, we said the period wasn't affected, so the period is going to go from here to here. It is one full period, and that one full period is 2 pi distance on the x-axis. The amplitude A is 3. Now the amplitude is always going to be a positive number because we take the absolute value of A. So if I ask you for the amplitude and that would have been a -3, you would have said that the amplitude was 3. I don't really like that. All it's saying is that the values are multiplied by 3. But A is equal to 3 in this case. Okay, so there's that graph. So notice, again, the only difference is the crests. So this is called a crest. The crest is just 3 times higher. Okay. Now the next graph, see it's sine of 2x. The other one had the 3 in front of sine. This here is going to be omega, which is a symbol, looks like a W. This does affect the period. So the period for sine of x is 2 pi. The period for sine of 2x is half of that, so it's just pi. So what ends up happening here is that 2 divides the period of sine. So really the way you could do it is you're really going 2 pi over the omega, which is 2 pi over 2. And again, remember period is t. Our period is going to be just pi. So now the points that I'm going to use, again, are easy points to find with the unit circle. So sine of 2 times 0 is going to be sine of 0, and sine of 0 is 0. So we get the origin again. At pi over 4, that's going to end up being 1, but I'll show you how to do that. It's going to be sine of 2 times pi over 4, but pi over 4 times 2 really is sine of pi over 2, and sine of pi over 2 is 1. So that's going to be 1. At pi over 2, then, sine of 2 times pi over 2 is really going to be sine of pi, and sine of pi is 0. So we're going to get 0. And then sine of 2 times 3 pi over 4 is going to be sine of 3 pi over 2, and sine of 3 pi over 2 is -1. So we see that that's going to be a -1. And then sine of pi, right, if we put pi in, it's going to be sine of 2 times pi, and sine of 2 pi is 0. So we're going to get 0. So now we see that the period here is from here to here. That's going to be 1 period. And our graph is going to look like this. And I'll just do it in a different color so you guys can see. We can follow the pattern. There, there, and there. And I'm doing it in a different color just so you guys can see the black is 1 period. And it goes like this. It's really not too bad. It's just substitution to plug in. But having the unit circle available to you to be able to graph these is important and critical. So I suggest that you have that with you at all times. And really what I would do is I would work on memorizing it because it will be so beneficial. Let's go on to cosine and see what cosine looks like. So with cosine, again, I'm going to use values that were easy on the unit circle. And cosine of 0 is 1. Cosine of pi over 4 is radical 2 over 2, which is again 0.707. It's 0 at pi over 2. It's a negative 2 radical 2 at 3 pi over 4. It's a negative 1 at pi. It's a negative radical 2 over 2 at 5 pi over 4, which is again that negative 0.707. It's 0 at 3 pi over 2, and then at 7 pi over 4, we get back to the positives for the x value, and then at 2 pi, cosine of 2 pi is 1. So when I go to plot this, I'm not going to plot all these points, obviously. I'm going to pick ones that are simple. So like 0, 1, that's an easy one to pick. Pi over 2 and 0, that's that one. Pi and negative 1. 3 pi over 2 and 0. And then 2 pi and 1. And again, cosine is an even function, so we see it's going to follow that pattern. And so the graph here is what cosine looks like for 1 period. So that's from there to there. That's 1 period. And we see that that 1 period again is t is 2 pi distance. And just so you guys can see what the wave looks like as it goes on and on and on, it looks very much like sine, except there's a shift. We'll talk about what that shift is in 2.6, but cosine and sine are essentially the same wave with just a shift, a small shift to the right or to the left. It's funny that sine and cosine together make every wave that's possible. So there's cosine. Now let's try to do some problems that are a little bit more complicated. So now let's include a amplitude and a period change. So that will be a period change. So we can see that the period change for this guy is basically going to be halved. So that 2x, remember, the period is going to be 2 pi divided by 2, which is telling you that the period is going to be pi. And the a for this guy is going to be 3. So when I do this chart for you, x and y, I'm going to use 0, pi over 4, pi over 2, 3 pi over 2, and pi, because that's the full period right there. So we can see that the period is only going to go from here to here. That's going to be 1 period now. So that means that this picture over here, this black wave, is going to be in just that short of a section. So let's do the math behind it. So cosine of, what's 2 times 0 is 0. Cosine of 0 is 1. And then multiplied by 3 is going to give us a 3. So again, 2 times 0 is 0. Cosine of that 0 is 1, and then multiplied by 3 gives us a 3. When I plug in pi over 4 for x times 2, that's the same as pi over 2, so cosine of pi over 2 is 0, times 3 is still going to be 0. When I plug in pi over 2, 2 times pi over 2 is pi. That's going to give me a -1 value, times 3 is going to give you a -3. And then by that same reasoning, that's going to be 0, and that's going to be 3. So when I plot these points, I'm going to go 0, 3, pi over 4, 0, pi over 2, -3, 3 pi over, this should be 3 pi over 4. My apologies. 3 pi over 4 is 0, and then pi is, again, 3. And so our graph, we can see, is heavily amplified. And that's what it'll look like. Now, if I continue the graph, we could follow the pattern, and we see it looks like this. Oops. That's terrible. I want to make sure I do this right for you guys. And then it keeps going. But you can see how the wave is gotten more compressed and is being amplified. That's the critical mass to this one. Now let's really take on a problem. Let's include an amplitude, a change in period, and then this will be a shift down. So, I know that the amplitude is going to be -4, but really it's just multiplying everything by -4, so really we'd say the amplitude is 4. The period, interestingly enough, is going to be 2 pi divided by pi, which is going to give me a period of 2. So you can see that my x-axis, instead of having it in terms of radians, I'm using just whole numbers, 1, 2, 3, 4 for the x-axis. And that's because the period's been changed to just simple numbers. Now, let me show you the math behind this so you guys can see this. One of the things that's important for this is, in this guy, a period is going to go from 0 to 2, so that is going to be what one period is. So let me show you how I would find this. So I'm going to pick some values that I know are pretty simple. And then since I know what cosine already looks like, I know how to draw it based off of just 3 points. So I'm going to use 0 first. So I'm going to go -4 cosine of pi times 0, and then -2. That's going to give me a -4 cosine of 0 -2. But we know that cosine of 0 is 1. So -4 times 1 is -4, or -2 is going to give me a -6. So at 0, my y value is a -6, and so I'm going to plot my point right there. Okay. Let's try 1. So, and part of the reason I'm choosing these values, just so you get an idea, it's because they're the points that get me to the crest and to the trough. Notice that really there's 5 key points that I use, and so what I'm using in this bottom example is I'm using the crest, a crest, and a trough to be able to get my values. So since the period is 2, half of 2 is 1, and 0 is the other endpoint. So I know that I'm going to have a crest at 0. And again, I should have that same value at 2. So let's try 2 real quick so you guys can see that I'm telling you it's going to be that same value. Just like over here, this one and this one give me the same value. So I'm going to go -4 cosine of pi times 2 minus 2. So -4 cosine of 2 pi minus 2. But cosine of 2 pi is 1. So I'm going to get -4 minus 2 is in fact that -6. So I'm getting that value. Now halfway between those 2 points is 1. So I'm going to use 1 and see what I can do. So -4 cosine of pi times 1 minus 2. So -4 cosine of pi minus 2. But cosine of pi we know is a -1 minus 2. So that's going to give me 4 minus 2, or the value 2. So I'm going to get this point right here. So now my graph is going to look like this. And then if I want to extend this graph, I can do that. I know that between, I know that at 3 I'm going to get -2, or I'm going to get 2, and at 4 I'm going to get a -2, and so this thing's going to look like this. And over here, again, because cosine is even, I'm able to follow the pattern going the other way also. So that's just some ways, some tricks to try and do these graphs. Please feel free to email me questions, and I'll try to post them on our discussion boards for people to understand. I hope you found this helpful. As always, all the best.